Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question, minimum window substring. So in this question, I'm given two string s and t of ranks m and n respectively. And I will return the minimum window substring of s such that every character in t, including duplicate, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. Okay, so for example, one, I will be given S and T and I will return blank. So in this question, the input is S and T, two strings S and T, and yep. And the output is string, which is shortest string. Shortest substring of S, which means condition. Okay, and that condition is every character in T is included in the window. So say T is like ABC. In that case, I have to find the substring which includes all the characters A and B and C, yep, as the substring of S. And I will return the shortest one. Seems like if there are two, say AA, like example 3, I have to find a substring with two AAs. Only single A isn't enough. And also, as I can see from example 1, I don't have to take care of the characters which appears in the substring. So in this case, T is ABC, but I can find these characters in the substring as BAC. Yeah, the order doesn't matter. Okay. So that being said, I will think of this question with some examples. Oh, by the way, S and T is more than 1 or equal to 1. Okay, so S and T, each of them is not an empty string. And S and T consists of uppercase and lowercase English letters. Okay. So let's say S is like this, and I'm looking for A, B, C. One thing I can say is the order of characters in this T doesn't matter. Yeah, I don't know if it worth mentioning, but I just noticed it. Anyway, so I think I can use the sliding window. That's my guess, but I will quickly mention the brute force approach. So as a brute force approach, I will take a look at each possible substring of S and confirm that includes all of the characters in T. Yeah. So in that way, the time compresses should be n cubed because I can start the ev- number of possible substring in S is n squared because I can take the first character and also I can take the end character. So n times n minus 1 combination of, start and end character positions. Then for each substring, I have to take a look at each character in S to confirm that it includes all of characters in T. Oh, so actually, it more than n cubed, it should be this. Because when I check if the specific substring includes all of the characters in T, definitely what I can do is create the counter, check counters of T. Then as I go through the substring char, I will decrement the count from T counter. Then if all the characters of the counter are value 0, that means that I could find all the characters in T in the substring. Yep. So this is the brute force approach. Then I will think of the optimized approach. So here, definitely I can use the spreading window in my guess. So let's think the minimum window substring, which includes all those characters in T, and which ends with this A. So when I think of that, I have only one choice. I begin from A and ends with A. And I will check if this includes all of the characters of T. And no. So there isn't any substring which ends with this A. Yeah, that meets the condition. So then I will, expand the scope window and I include the B, but still a B doesn't include all of the characters. So I expand it and expand it and I will keep expanding it. Then once I reach, let me change a little bit. Once the end index reaches the C, what happens is that the characters included in this window is ABDABC. This includes all of the ABC char. So now this ABDABC meets the condition. However, also I can think how much I can shrink from here. So I will shrink from the, head of the substring. So let's see if I can exclude this A. Yeah, it's possible because A is already included in the window, and B possible, D possible because it's not in the ABC. Then here in A, I cannot because if I exclude this A, the window doesn't include any A. So this is it. Next, I will think of this. Let me change it to A. Okay. I will think of the window which ends with this A. And here, I can start from here. Because it guarantees that if I start from this A, I can find the substring which includes all of ABC. Yep. So I can start from here. And I also think how much I can shrink this time. So obviously I can pop out this A. So this is it. So in this way, show this substring is ABC. Okay. Good. Or BCA. Yep. So this is it. Yep. So as I said, this is the sliding window approach. So I think I can use it. So let me quickly, sort out the approach in sentences. So Yeah, so this is it. Okay. So I will start the implementation. Yep. Okay. So here I've implemented half of my method, but let me quickly works explain. So I initiated winning stop, which should be returned in the end, and also window chars, which includes the chars in the window in string s. Oh, and I took a look at for each end what happens. So window chars should be, new char in S should be appended to the window chars first. Then from here, so what I can do is, so as I said, if this window charts has the enough, all of the, charts in, T, then I update the window charts. Yeah. But one thing I have to take care from here is that if I take a look at each chart and compare, the window chart and counter of charts of T, it takes all of, say, all of T time. Yeah. But I try to do it in the constant time. So I have to be a bit arrogant here. So let's me think how I can, meet this. So definitely what I can do is instead of, let me, okay. So what I mean by here is that, for example, here, now the window charts includes in this way. But actually, I can just forget this D because this is not included in the D. And I will take a look at A to B to C1. And let's say, let me quickly change the question. T like this. So in this case, counter should be this. So what I'm talking is how I can check if this window charts include all the charts in these teachers. Yeah. And as I'm saying, I don't want to iterate each char in the window chars. Yeah, because it can take all of t time. But instead, what I can do is every time I update the window chars, I will check with these teachers. So for example, if A is 1 and then A is appended and A becomes 2, I will check this and this compare. And if this, is exactly A is equal to 2, which is the count of the A in T, then I would say I increment this. Satisfied chairs count. So here, if A is met, this becomes 3. And also when I shrinking the window, like when I shrink the start index, I have to pop up some element, say like, yeah. Oh, actually, in that case, satisfied chest count will not be decremented because if I move the start endpoint, start index, and it becomes, if the condition becomes not met, then I don't want to move the start index. Actually, satisfied chest count will never be decrement. Yeah. So I can just think of how this increases, this count increases, and until the number of unique chairs in the T. Okay. So this is something I can use. So let me use it in my implementation. So here, after okay, so here in line 48, I will do this increment only if this char is in teachers. Okay. So here, I have to think if at the current moment, the, window chars includes all the characters in S, no, in T. Yeah. So if this meets the condition, if this doesn't meet the condition, I will just continue. Because I cannot shrink window or count. I mean, updates the mini sub with this. I just can continue. So if this meets the condition, the first thing I can do is shrink as much as possible. start node in teachers, or if start chair is not in the teachers, I can just pop it out. Or even if this is in teachers, still if I pop out that char, there is enough count. In that case, I can shrink the window by moving the start index. So this is a char which should be popped out. Like this. So number of start char in the window is more than the number of chairs in teachers. Yeah, in that case, I can shrink. Okay. So here, after shrinking the window, I will check, yeah, if I should update this substring. Mini sub with this substring. Oh, but I don't want to initiate the substring here, because if I do that, in the worst case, I have to initiate the substring every time for each end index. So I just, in line 42, I will just keep track of the start index and the index tuple. Yeah. So in this way, I don't, have to initiate substring every time, which means I can save the time complexity. Okay, this is it. So in the end, in the last line of the final function, I return something. Yeah, yeah, I can return this. Okay. So let me walk through my code. by the way, in line 47, if SN is not in teachers, I just can continue. Yep. Because I cannot shrink. Okay, say T has ABC and if I get D, this doesn't change anything. This D doesn't change anything. This means that I cannot shrink the window with this D because it's not included in the teachers. And also the minimum length will not be updated with this D because say there is ABC before D. In that case, ABC is still the minimum length. Yeah. Oh, I mean shorter than ABCD. So I can just update it in this way. Yep. Okay, so let me walk through my code. Oh, by the way, time compressed this should be O of S plus T because I mean in line 42, this takes O of T time to create the counter hash map. And aside from that, in line 48, I move the end index and also start index. Each of end index and third index start from 0 to index S minus 1. I mean, last index of S. So each of start and end moves at max length of S. So in total, it should be length of S. Yep. Aside from that, all the operations in the, for loop is constant time because I use the satisfied church count trick. Okay. Then in line 74, I initiate the substring. This can take all of S time. Yep. In the worst case. So in total, it should be all of S plus T. Okay. And for space complexity, I need the window teachers, which can take up to T. And I need window chairs. This, in the worst case, has all the chairs in S, and they're unique. In this case, the space complexity of it is O of S. Yep. Basically, that's it. So the space complexity should be O of S plus T. Yep. I initiate the, in line 75, I initiate the string to be returned, but I don't include it in the space complexity. But even if I included this into the space complexity, this substring can take up to O of S space. So in total, it should be O of S plus T. Good. So now I will quickly walk through my code with very easy case. Yeah, let me go with this. Okay, I'd like to make it very simple. Let me just make it like this here. So teachers should be like this. And window chairs begins with empty window counter. Satisfied chairs count begins with 0. And mini sub begins with this. Okay. And the start begins with index 0. Okay. And end moves with for loop. So in line 63, end is now index 0. And in this case, S end, which is B, is in teacher's key. No. Oh, wait. So let me change this example. Okay. Okay, so in this case, in line 64, S end, which is B, not in teachers. No, this is true. So I go to, S end is included in teachers. So I go to line 67 and window choose S end plus equal 1. So B is now 1. And in line 68, window, if Windows chars S n equals to the chars S n, satisfy chars count plus equal 1. I see. So here, window chars S n plus equal 1, I did. And in line 68, window chars S n, which is 1, and teachers S n, because S n is B, teachers from teachers, it is 1. Yep, so this is true. So satisfy chars count plus equal 1. This becomes 1 now. Yes, that this makes sense. No, this doesn't make sense. Wait, because I changed S. The first churning S is now C. So in line 64, this is not included in teachers. I continue. Sorry. This is term 0 and window choose is still empty. Okay, now I move the end pointer and S end, which is B, is in teachers. So I go to line 67 and window choose S end plus equal 1. So now C1 is, no, B1 is included. Yep. Then in line 68, window choose Sn, so which is 1, is equal to teachers Sn. Teachers Sn B is now 1. So this is true. The satisfied choose count is incremented by 1. Yeah. And here in line 71, satisfied choose count is now 1. And ranks of teachers is 2. So this is not true. So meet condition is now false. So I continue. Okay. Then I move end index. Now Sn is A. Okay. So A is in teachers. Yes. So I go to line 67 and increment it in the choose. Okay. Now in line 68, on the line, yep, line 68, window choose Sn. So it should be 1 is equal to teachers Sn, which is A, so 1. So this is true. So satisfied chess count is now incremented by 1. Yeah, now it becomes 2. In line 71, satisfied chance count is now 2, and Rangus teachers is 2, so this is not true. Okay, so I go to line 75, and now this is the shrinking phase. The S start is not, B. Yeah. This is CBA. Yeah, how could I do with this mistake? But basically, the logic, from the logic, I think, assume what I was doing is correct. So now, in line 75, S start D is not in teachers, yes. So I go to line 76, and window chairs as start minus equal 1. Oh, this is a kind of problem. Only in this case, I have to decrement. Otherwise, I don't have to, because S start doesn't appear in window chairs. Okay, so now S start C is not included in the window chairs, so I don't have to do this. And I go to line 78, and start is incremented by 1. So now start is now 1. Okay. And I go back to line 75, and S start B is in teachers. Yeah. So this is true. Yes, no, this is false. So I go take a look at the second condition. And teachers S start plus 1. So teachers S start is now B. So this is 1. And window chairs S start is now 1. So this is false. Yep. So I cannot shrink the window anymore. I go to line 80, and now ranks current substring is n minus start plus 1 is 2. Yep. Length of mini sub is now infinity, because infinity minus my negative infinity is infinity. In line 83, length current sub 2 is smaller than length mini sub. Yes. So mini sub is now start end 1, 2. Okay. So that's the end of the iteration. I go to the for loop of line 65, and I go to line 88. The mini sub is not mass infinity upper, so I go to line 91 and start in this 1, 2. So I return the substring of index 1 to 2. So it should be BA. Good. This is as expected. Okay, I think I covered most of my implementation, but I think the case I couldn't cover, the line I couldn't cover was line 79. I didn't check it, but I'm pretty sure this is logically correct. And also, I couldn't cover line 89, the case when there isn't any substring, which means the condition. Yep. In this case, also, I'm pretty sure this is logically correct. Okay, so I'm pretty confident in my code. I submit. Good. Great. Okay, so I will quickly wrap up my today's coding practice. So today I solved the question, minimum Windows substring. Yep. And in this question, I'm given two strings S and T, and my task is to find the substring of S. I mean, the shortest substring of S, which means the condition, and the return is. That condition is that for that substring, it includes all the chars included in the string T. So that's the condition. Okay. And for this question, I use the sliding window approach. So for each substring in S, I will think of the ending index, and yep, I should say I traverse the ending index of the S, and if there is a valid string, I update the returned one with that, basically. Yep. And in that way, and also with one small technique, that is for chars counter, I could solve this question in of s plus t time compressed t. Yep. Assuming st is the ranks of s and t. Okay, that being said, I finished my today's coding practice. Oh, wait. Yeah, good. Okay. Thank you.